Construction of the Paducah gaseous diffusion plant began in 1951. By late 1952, the first enrichment stages in the C-331 building were operating. The Paducah site covers more than 3,500 acres and includes more than 500 facilities and structures. 19 miles of roads surround and cross the site, along with 9 miles of rail lines connecting 3 rail systems. As we enter the site, you will notice the sign indicating this is a DOE site. Our tour will take you through the Post 213 gate to the property protection area for the DOE Paducah site and into the industrial areas to see the massive gaseous diffusion process buildings and supporting facilities. The site is home to over 1,400 DOE and contractor employees who work to deactivate the facilities, perform waste disposition, execute environmental cleanup activities, and right-size utilities to support the cleanup effort. The massive site is much like a small town requiring comprehensive site infrastructure services, including roads and ground maintenance, facility maintenance, along with safeguards and securities, medical, IT, and cybersecurity services. The building on the left is C-103, the Paducah DOE Local Site Office, which is part of the Portsmouth Paducah Project Office in Lexington, Kentucky. Although DOE manages the cleanup program out of the Portsmouth Paducah Project Office in Lexington, day-to-day operations are managed by the Paducah site lead with a team of DOE project managers and support staff. On each of our facilities, you will see labels. C stands for Paducah, and the buildings labeled in the 100s refer to administration. Now, let's turn right in the C-100 parking lot. The building in front of us is the C-333 process building. It's an 80-foot, 2-story building that covers over 25 acres. That's as big as 20 football fields. After we enter the gate, we'll drive up to the building and I'll tell you more about it. This is the C-100 building. It housed the administration team that operated the enrichment plant before it ceased production. Today, contractor personnel use most of the office space to manage the cleanup program. We will be going inside the industrialized area. The workers refer to it as the limited access area, but you will recognize it as the fenced area. This area requires a security clearance for entry. Those requiring entry without a clearance must be escorted. We have now entered the limited area, which is a higher security area. In front of you and to your left is the C-300 Central Control Building, which is the main control facility for the site. The round facility was built to withstand an attack. Note the domed roof. The roof was designed to deflect a bomb so the control room could continue to function. The C-300 Central Control Facility was the plant's brain center. At the time of its construction, the C-300 Central Control Building was one of the most sophisticated buildings of its kind. Built in 1952, the 16,000 square foot C-300 Central Control Building is used to monitor, coordinate, and control critical plant processes, including plant distribution, utility communication, plant alarm systems, and emergency communications. To put the size of the facility in perspective, the average size home, according to the latest census, is a little over 2,300 square feet. So, about 7 average size homes could fit into this facility. More than 10,000 miles of cable, enough to stretch almost halfway around the earth, supplied the Central Control Building with electronic information from the plant's process systems. From this facility, any of the 4 process buildings could be shut down, even though all 4 buildings have their own control room. Note the C-333 process building on the right and the C-331 process building on the left. These were the first 2 process buildings ever constructed. In total, there are 4 process buildings. The 2 larger process buildings occupied nearly 25 acres per floor, as big as 20 football fields, and each is more than 80 feet high. There are 2 smaller process buildings. Each is 68 feet high and covers nearly 12 acres. To describe the sheer size of the C-333 process building, you can lay down the Empire State Building diagonally inside the building. These process buildings were designed to shed heat. There's no insulation. They are designed primarily to support the great weight of the machinery, so they have a lot of vertical support girders, but the exterior walls are primarily transite panels. All the buildings are connected with piping. Many of these pipes are 30 to 40 inches in diameter or large enough for a person to crawl through. Now that the plant has ceased operation, a process is being implemented to remove leftover deposits such as uranium before the facilities can be demolished. The enrichment process at the gaseous diffusion plant occurred primarily in 4 large buildings, some of which we just saw. The gaseous diffusion technology consisted of approximately 1,760 stages. The C531 switchyard is one of 4 that provided power to the site. The plant was built with capacity to use up to 3,000 megawatts of power. While the plant uses a lot of power, the enriched uranium the plant produced had the ability to generate even more power through its use of nuclear power reactors. The switchyard stepped down power from the incoming 161,000 volts to 14,000 volts that previously ran process equipment and supported facilities. To put this in perspective, a regular outlet at your house is 120 volts. Today, the site's cleanup mission only uses 8 to 12 megawatts per hour. This reduction in energy requirements provided an opportunity for DOE to reduce energy cost and consumption by constructing a new electrical substation and power distribution system operated by the Tennessee Valley Authority, known as TVA. By the end of 2021, DOE safely took Paducah's last remaining switchyard offline and transferred electrical loads to the new TVA substation. In 2022, DOE completed the partial dismantlement of the C537 switchyard. Several components from this project were transferred to the Paducah Area Community Reuse Organization called PACRO for reuse and recycling. In total, PACRO has received over 500,000 gallons of insulating oil and 113,000 pounds of recyclable metals from deactivation work conducted at all 4 switchyards, which has boosted regional economic development efforts. Next is the C400 cleaning building. This building was used, among other things, to clean parts while providing other cleaning needs for the site. A degreaser agent called trichloroethene, called TCE, which was a very common and effective degreaser, was used in this building. Its use resulted in a major source of groundwater contamination. At the corner of this building was a large tank that held TCE that was piped into the building. TCE leaked underground from piping connecting this tank to the building. When groundwater contaminated with degreaser was discovered off the plant site, DOE responded by providing temporary water supplies to residents potentially affected by the discovery. To protect the public long term, DOE extended municipal water lines at no cost to the properties that had groundwater wells that could have been affected. DOE continues to provide water to the affected residents. DOE and its contractors implemented a program to address the groundwater contamination and to prevent the spread of the contamination. One of the things we do to reduce the contamination of groundwater is to extract the water and clean it. The Northwest Plume Pump and Treat Facility is one of 2 of the pump and treat stations in operation since the mid-1990s. As of March 2022, DOE treated more than 4.7 billion gallons of contaminated groundwater using 2 groundwater systems. Today, DOE continues to study and evaluate actions to further reduce the levels of groundwater contamination that originated at the C400 complex. The C720 Maintenance and Stores building has about 336,500 square feet of floor space. That's nearly twice the size of the average Walmart supercenter. The C720 Maintenance building was an active machine shop. It was integral in the startup of the plant, the upgrade work that has been performed at the plant, and the Work for Others project. This building also housed purchasing, carpentry shop, and shipping and receiving. This next area, located in the southwest portion of the site, is defined as Solid Waste Management 211A, or SMU 211A, and is believed to be a contributor to off-site groundwater contamination. Previous investigations demonstrated that bioremediation is an effective treatment technology to degrade TCE and other volatile organic compounds present at SMU 211A into non-toxic chemical compounds. In March 2022, the site took steps to eliminate TCE and other substances from this area with the use of a bioremediation project near the C720 machine shop. The Large Item Neutron Assay System Linus facility houses scanning equipment to support the deactivation of several facilities, including Paducah's 4 process buildings. Deactivation is the process of placing a contaminated excess facility in a stable condition while preparing it for future decommissioning and demolition. Linus scans and measures the neutron particles emitted from the uranium deposits inside large equipment removed from the process buildings. Measurements from the scans are used to determine how the equipment will be disposed. The Linus chamber, where the scanners will measure neutrons emitted from the equipment, has 3-foot thick ceilings, 2-foot thick walls, and 18-inch thick doors to ensure any natural radiation present in the environment is blocked during scans to improve the accuracy of data generated from the scan. The Paducah site has its own first responders who are trained to deal with all types of potential emergency conditions, from firefighters to protective force and on-site emergency management facilities. As the mission at the site has changed, the need to centralize these organizations on-site became imperative to ensure the future needs of the site are met. In 2022, DOE began construction of a new safeguards and security complex and a centralized emergency management operations center, providing a central hub for emergency response organizations. The safeguard and security complex houses the site's protective force officers, personnel security, firing range, and training areas. The Emergency Operations Center is a hardened facility capable of withstanding severe weather while operating independent of plant utilities if needed. A cadre of trained personnel meet in this facility to respond to and recover from potential emergencies at the site. A co-product of the uranium enrichment process is depleted uranium. The DUF6 facility converts depleted uranium, DUF6, into an oxide, a more stable chemical form suitable either for reuse, long-term storage, or disposal. Hydrofluoric acid, HF, is a byproduct of the conversion process and is sold for industrial reuse. One use for HF is to etch glass. The DUF6 inventory at Paducah is 46,000 cylinders and is estimated to take approximately 30 years to process. The plant employs about 214 people, and it's designed for 24/7 operations. The conversion method is a continuous process where DUF6 is vaporized and converted into uranium oxide in a fluidized bed conversion unit. The process equipment is arranged in parallel lines, each line consisting of 2 conversion units, an HF recovery system, and process off-gas scrubbers. In the conversion process, DUF6 reacts with steam and hydrogen to produce uranium oxide and hydrogen fluoride. Future industrial use for the site has been identified as a primary focus for the community. An area adjacent to the DOE property boundary is a projected site for a potential GLE laser enrichment site. GLE signed an agreement with the Paducah McCracken Industrial Development Authority with an option to acquire the parcel of land. The GLE plant is expected to provide several hundred permanent jobs for the Paducah area. PPPO's vision for the site is to safely accelerate the cleanup, ensuring protection of the public and the environment, support reindustrialization for southern Ohio and western Kentucky, and work with local communities to provide land and attract private industry to provide opportunities for jobs and economic growth. As we drive along the east side of the site, you will see land that has been identified by the community for potential reuse by private industry. DOE is currently evaluating areas with near-term reuse potential.